Here we're asked to solve an equation by factoring, and the reason why we wouldn't be able to solve this by isolation, the way we normally would in grade 9, by just getting x by itself, is because we have an x squared term and an x term. These are not like terms, so they can't be combined, and so we wouldn't know which x to isolate, and even if we picked one, what we'd kind of get is x equals a bunch of stuff that has an x in it still. That's not what we're looking for when we're trying to solve an equation. We want to know what numbers we could use as x values that would make the left side and right side equal to each other. We're not getting any numbers out of this. So, in order to solve by factoring, we want to have 0 on one side, so we need to move all the terms over to one side. And we'll talk about why we need this later on. But for now, just remember we need 0 on one side. And now we factor. So two numbers that multiply to 18 and add to 11 are 2 and 9. So I'll decompose the 11x into 9x and 2x. We need to common factor the first two terms. The common factor there is an x. And here my common factor is a 1. We have 2x plus 9 as a common factor for this term and this term. So we'll common factor out the 2x plus 9. And what's left? An x plus a 1. So now we have two things multiplied together, and that's giving us 0. There's only two ways that that could happen. Either 2x plus 9 is 0, so that we're doing 0 times some other number to get 0, or it's x plus 1 that's equals 0, and we're doing some number times 0 to get 0. So we can say 2x plus 9 has to be 0, or maybe it's the x plus 1 that has to be 0, but it's one of those two things has to happen. So here we can solve by isolating. We'll subtract 9 and divide by 2. With the other equation, we just have to subtract 1, and there we have our two solutions. Now I said that we'd talk about why we need to have 0 on one side. So let's see what happens if we don't do that. We don't get 0 on one side first and just start factoring right away. So two numbers that multiply to 30 and add to 11 are 5 and 6. So I'll decompose the 11x into plus 5x plus 6x. Common factor for the first two terms is an x. For the second two terms is a 3. Now I have a binomial as a common factor. I'll factor it out. That leaves me with an x and a 3. So when we had 0 on one side, and we got to this point, we were able to say that the only way we can multiply to 0 is if it's 0 times another number, or some number times 0. To multiply to 6, though, there are lots of ways that could happen. We could have 3 times 2, or minus 3 times minus 2, or maybe it's this number that turns out to be 3, and this one that's 2. Or this could be minus 3, and that could be minus 2. Or maybe it's 1 and 6, or 6 and 1, or minus 1 and 6. So there are lots of possibilities, lots of ways to multiply to 6, and we haven't even gotten into, well, maybe it could be 12 times a half, or 24 times a quarter. So there are way too many possibilities to try to explore when we have two things multiplied together and it equals anything else but 0. We really need that to be a 0 so that we can say, hey, the only way you can multiply to 0 is if the first number is a 0 and we're doing 0 times something, or maybe it's the second number that's 0, so we're doing something times 0. So this really is going to be a lot of a mess over here, so we just get rid of that. Okay, so again, we want to solve by factoring, make sure we have 0 on one side. We're going to factor, and then we use a bit of logic. We've got two things multiplied together to equal 0. The only way that can happen is if one of the numbers is 0. So set each bracket equal to 0, set each binomial equal to 0, and solve to see what x value would make this equal to 0, and what x value would make this equal to 0.